Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, one day late. And today we're going to be talking about cloud layers and cloud types, and also some of the interesting optical effects that can go on with water droplets and also with ice crystals. So as we usually do with these bonus weather videos, we have a little message before we get into the crux of it. And since we're talking about cloud layers and cloud types, I urge you not to take this too seriously, okay? All right, so let's talk about low clouds first, and I am going to attempt to take myself out of the picture here, because if I don't, I'm going to be blocking the information, and I don't want to do that. Okay, so now I'll go back up here and click, and let's talk about low clouds. They occur below 6,500 feet, and they're mainly made up of liquid water droplets or supercooled water droplets. Now, what do I mean by supercooled water droplets? Well, it turns out that water droplets condense on what we call condensation nuclei. And the nuclei that lead to the condensation with water droplets are much more common than ice nuclei are. And so when temperatures go below freezing, if there aren't any ice nuclei around, it's very possible for these water droplets to continue to exist in the liquid water state, even though the temperature is below freezing. So that's what we mean by supercooled water droplets. Now, the only exception, of course, is during the winter when temperatures can be quite cold, and then the odds of the water droplets being in a frozen state, or actually with ice crystals, is much, much greater. Now, stratus clouds develop horizontally, okay? Stratus is a word that implies flat, and so if the clouds are relatively flat, then we refer to them as that. Cumulus clouds during the wintertime, or during the summertime, if you see the beginning of the big thunderstorms where it looks like a bunch of cottony clouds that are billowing upward through the atmosphere, those are what cumulus clouds are. And if they grow into clouds that cause rain, then we call those cumulonimbus clouds, which is a fancy word for thunderstorms. And then we also have what we call a hybrid cloud, which would be stratocumulus, and it's relatively flat, but it sort of has a cellular appearance to it. And I'll show you pictures of that right now. Now, these are the low, flat stratus clouds, the ones that look pretty ugly. And when they produce rain, they're extra ugly. And then over here, we have the cumulus clouds, which are billowing upward through the atmosphere. And then these are the stratocumulus clouds, which are relatively flat, but you do see some breaks in the clouds here and there, and so it has a little bit of a cellular appearance. Now, mid-level clouds occur between 6,500 and 20,000 feet, and again, they are composed of liquid water droplets, supercooled water droplets, or ice crystals, depending on the time of year. Alto stratus clouds are relatively flat. The word alto, or the prefix alto, refers to mid-levels. And alto cumulus clouds will either have a cellular appearance to them or in some cases can have some vertical development. Here are some examples of that. This is the alto stratus clouds. It can still have some rolly, let's see, how do I put this? Looks like you can have rolls here, like here's one roll, second roll, third roll, but it's still overall flat. And then over here you have the alto cumulus clouds, which have a bit more of a cellular appearance to them. Finally, the high-level clouds occur above 20,000 feet, and once you get up to that elevation, the clouds are primarily composed of ice crystals, and we have cirrus clouds, cirrostratus, and cirrocumulus clouds. The cirrus clouds are thin and wispy, the cirrostratus clouds are relatively flat, and the cirrocumulus clouds have a more cellular appearance to them. Here are examples of that. These are the cirrus clouds. I'm sure you've seen those many, many times. This is cirrostratus, where it's relatively flat, and this is cirrocumulus, which again has more of a cellular appearance to it. Now, there are some interesting optical effects that can go on with water droplets and also ice crystals. So I thought you might find this interesting. Rainbows will always be on the opposite side of the sky from the sun. So in order to see a rainbow, the sun has to be to your back. You will never see a rainbow on the same side of the sky as you do the sun, and we'll explain why in just a little bit. Now, sundogs, which are little arcs of color that occur on both sides of the sun, will always be on the same side of the sky as the sun, because we're dealing with the refraction of light through ice crystals. And so the ice crystals are between you and the sun. The sun's rays interact with the ice crystals and create the colors that you see. So let's get into this a little bit more graphically here. Here's the sun. Here's a set of eyeballs. And here's a water droplet or a rain droplet. So the rays from the sun hit the water droplet. They get bent or refracted a little bit. They bounce off or reflect off the back of the raindrop and then get refracted again back to your eyes. And so this explains why the sun has to be to your back in order to see a rainbow, because they're caused by liquid water droplets, and you need to get that refraction and reflection going on within the drop. Now, in the case of the ice crystal, here's the eyeballs, here are the ice crystals, and here's the sun. So the rays from the sun interact with the ice crystals. They get refracted or bent, and that splits the light from the sun up into all the colors of the spectrum, which then gets to your eyeball, and you see those little arcs of color on each side of the sun. Now, if you remember back to your school days, you may have learned about a gentleman by the name of Roy G. Biv, and it helps you to remember what the colors of the spectrum are. And so we have red, okay, for R in the Roy, and then orange, yellow, green, blue, indigo, and violet. Okay, so those are the same basic colors. And if you have a graphic system, which I had to work with for years in television, you actually have what we call RGB values, red, green, and blue. And so for red, you would have 255 levels of red, no green, no blue. And then if you mix the red and the green, then you get orange. And so you can mix these colors up any way you want to get the exact color that you desire. Now, the red colors have the longest wavelength, and the violet colors have the shortest wavelength, okay? So we have white light coming in from the sun, and the white light is made up of all the colors of the spectrum. Like when I just talked about the graphic system, if you have 255 reds, 255 green, and 255 blue, that's going to translate into a white color, okay? Now, the longest wavelengths actually get bent the least. So the light from the sun comes in, and it gets refracted or bent, and so the red gets bent a little bit, the orange more, the yellow more, the green more than that, the blue more than that, the indigo more than that, and the violet the most, okay? And that's why you see all of the colors, because that refraction process is splitting the white light up into all the colors of the spectrum. Okay, so here is a water droplet, okay? Here's the white light coming in from the sun, and as it enters that raindrop and the refraction begins, the red gets bent the least, the orange the most, the yellow, the green, the blue, the indigo, and the violet. Then, when it gets to the back of the raindrop, it reflects, okay? So here's the red getting reflected, the orange, the green, the blue, the indigo, and the violet, and then the light comes out the other side, and this is what gets to your eyes, okay? The red, orange, yellow, green, blue, indigo, and violet, okay? So the red will always be on the top edge of the rainbow, if you will, and the violets will be on the bottom. Now, every once in a while, the raindrops will reflect twice off the back of the raindrop, and you will get what we call a secondary rainbow, and the order of colors will be reversed. So if you see a secondary rainbow, the red will be on the bottom, and the violet will be on the top, and every once in a blue moon, you'll get 3 reflections off the back of the drop, and then you have what we call a tertiary rainbow, or third rainbow, and the color order reverses again. So the red would be on the top, and the violets would be on the bottom. But that is a very, very rare occurrence. Secondary rainbows you'll actually see every now and then. So hopefully that makes a little bit of sense in terms of the difference between raindrops and rainbows and sundogs, and how you have to have the sun on the opposite side of the sky from the rainbow. And you can actually make your own rainbow, okay? In the sense that when I worked at WRAL, they had the fountain out in front. And so if I position myself so the sun was to my back and the fountain was in front of me, I could make my own rainbow. And I did that a lot of times because I'm a nerd and I like doing things like that. So, all right, let me see if I can't put myself back in here. Let's see. There we go. All right. So that is bonus weather video number 1 for today. Hope that made a little bit of sense. Bonus weather video number 2 will be coming up on Friday. Hope you'll join us for that. And, of course, the next daily weather update will be coming up tomorrow afternoon. So hope you have a wonderful Wednesday evening, and we'll talk to you again tomorrow. Take care, everybody.